Got the right casting sent through, thanks very much. This clamp nut and this clamp and vice nut and this clamp, these are much wider castings than the drawing says they need to be. So the drawing says like 3/4 of an inch. Well, actually that's 31mm. It's about 1.1/8. So these pieces would best, for strength wise, these pieces would best be left as wide as possible. So I'm just going to trim these down for 20 to 25mm, just to give me a dimension to aim at. That one's 32. It's quite a bit of draft on the casting, so give myself plenty of room to get all that off. But I'm not going to do them to 19mm 3/4. I'm going to make them 25mm deep. The other thing is to machine this end off as little as possible, if at all, because I want to preserve that cutout to let the vice screw go through. So most of it's going to be kind of top down from there. Similarly with this nut, I've got to be conscious that I need to leave enough material here to take the hole in the thread. So that will likely be top down as well. These are small enough to fit in the vice, so it's all going to be vice work on the mill, most of it. I like using a fly cutter for this because it gives a flat surface a good finish, and you can just keep sharpening that. If you start making end mills blunt, it's a big faff to resharpen them. I can do it on the ends, but try to avoid it. This is just disposable tool steel and easy to sharpen. I'll take a bit more off than that because it's not cutting through the skin. Now there's two reasonably flat surfaces parallel to each other. You can hold that directly in the vice, so I'll go ahead and square off the sides and the ends and start measuring. I want to make sure that this lead screw, vice screw relief stays in the centre of this piece. So clamping a 14mm end mill into that groove, zeroing it there, and I've got 10.60. .6 on that side. I'll bring this over now. Zero that there. I've got 10.56 on there, so by pure chance it is actually still in the centre. So when I come to reduce down the width of this piece, I'll take just 0.18 oversized at the moment. Take 0.9 off of this side, turn it over, take 0.9 off the other side, measure it. That slot should remain in the centre of the part. So this has just got a centre drill in the middle of this part. I already knew what the edge was here, stepped over, took the edge on here, moved to the centre. I'm going to leave this as a centre drill right now because this is going to come out of the lathe to have a circular feature put on the top here. So it's got to go in the lathe for that. Might as well do all the drilling and tapping in the lathe as well. I want this a shade under 19, so it has to fit in the bottom hole of the jaw. dead on 19, but probably the jaw won't fit over that. Two things of the same size can't occupy the same space. Well, stand corrected. So I wouldn't have it in the drill chuck. Let's see how it gets on with the collet. Yeah, that made it happen. That should be the nut finished. The nut goes up under that jaw into that piece there. This gap clamping on this rail. Let's see if that works. It's got a good slide on there. Fits around that. That hole marvellously lines up. And yes, it clamps it down tight. Right, left hand thread M12. If I mess this up, I'll not be phoning them for another casting. I'll be going around the corner, buying a piece of stock and making it myself. Let's see what happens. Got to be the most uneventful thread I've ever tapped. It just shows you what a proper tap can do instead of a cheap one. I'm only going to start this off under power just so I can get it straight. I'll get it in till I can see kind of full threads going in. Then I'll just stop the machine, take it out, finish it off by hand. I don't want it running away with itself and then bottoming out in that hole. That's the problem. That'll do. What really matters is the 12mm up this end. .3. That's going to have to go into the bore on the bolster, so that's going to be a bearing. It's going to be a bearing portion of the screw. The rest of it down here, that's going to have all thread on it, so that's not going to matter how accurate that is. Just need to get it down so I don't cut the thread on it. 12.32. Now while the target was 12mm, 12.01 wouldn't have gone in a 12mm hole, so let's see what we've got here. 11.99. It really is a very nice finish. I'm not going to polish that at all even. Okay, next thing I've got to do is take it down to that blue line. So cross slide is marked on 0. I will come across, take it down to the blue line, then I'm going to have to reposition the tool to get in the corner. There'll be a very slight undercut on there, which is what you want in the corner. I'm going to put a brass thrust washer on this anyway, eventually. Yeah, it's come out not too bad at all. Right, so it's dead on 12 millimeters because that's going to be a bearing. This is down to 11.8 because that's going to take an M12 thread, and an M12 thread is not 12 millimeters diameter. This is 10 millimeters because that's going to be not so much a bearing but a location point. And then the last piece of that down to about 9.85 to take an M10 thread, because an M10 thread is not 10 millimeters diameter. The last thing I'm going to attempt is a little bit of an undercut in this shoulder here. That M12 thread is going to run into that 10 millimeter diameter at the end. I'm not really worried about the diameter here, but I need somewhere for the tool to stop so that it doesn't stop halfway through a cut and snap the tip off of the end of it. So a little undercut in here with a parting tool, and we're going to see how this goes. This is as risky as it gets. Got a little jack under the parting tool there to try and hold it up, try and take the slack out of the compound slide. Let's see how this goes. So take a 0 there. Enough. This brass washer is going to be just 1mm thick. That'll be like a little thrust bearing for the back end of the vise, so that the steel nut doesn't bear on the aluminium, which doesn't seem like a good idea to me. There we are, little brass washer underneath there, because that is the thrust end of the vice screw. So as you tighten the vice up, that is going to take the pressure. The other end of the screw never experiences any thrust load, because the thrust load it gets is when you undo the vice to move the jaws away from each other. It's this end that will wear out. This vice should all be done. So there's jaws with the screws that come with them. There is the work stop, which goes in the side, clamp, jaw nut, jaw screw, Tommy bar, two little Tommy bar buttons, that should be it. How does it go together? That's the vice done.